Right. Awesome. Yeah. Shall we get started? It was easy only, no? Prepared, huh? Let's see. So today we'll start with the next part of this chapter. This is the last part actually. Okay. So we started with the motion in 2 dimensions. We started with water vectors. Then we saw motion in 2 dimensions, that is projectile motion. Right. Now we'll see how to find the product of two vectors. Right. So before I start with this, let's say you have two numbers, 2 and 3. So you can perform different kinds of arithmetic operations between them. What are they? 2 plus 3, 2 minus 3, 2 into 3, and 2 divided by 3. So 2 into 3 is going to give you 6. So if you observe, 2 is a scalar, 3 is also a scalar. So when you multiply a scalar and a scalar, you are getting a scalar, right? So what kind of a multiplication you're doing? You are just multiplying the numbers and you're getting an output which is also another number. Whereas instead of me giving you scalars, if I give you vectors, right? Like I say A vector and B vector are the two vectors, find the product between them. Okay. If at all I put a question like this, then the first thing that you're supposed to notice, when you take two vectors, you cannot do the direct product between them. So when you talk about product of two vectors, there are always two kinds of operations that we can perform, in which the first one, if you see product of two vectors, what are the different ways in which a vector can be multiplied by another vector, for which the answer is, it can be done in two ways. One of the ways is called as dot product or scalar product. And the other one is called as cross product or vector product. Okay. So one is called dot product or scalar product, and the other is called as cross product or vector product. And the logic is very simple. When you perform the dot operation between two vectors, the output will be a scalar. That is why if you see, dot product of two vectors gives you a scalar vector. Okay. In a similar way, cross product of two vectors gives you one minute. Cross product of two vectors gives you a vector output. Okay. So having this in mind, what we can say is, if you observe, first we will start with dot product of two vectors. So write down the heading as dot product of two vectors. Okay. So if A vector and B vector are the two given vectors, then A vector dot B vector is given as, just give me a minute. So this is read as A vector dot B vector, and its value is given as magnitude of A vector into magnitude of B vector into cos theta. Okay, where this is obviously the magnitude of A vector, this is the magnitude of B vector, and theta is the angle between A vector and B vector. Is that clear? Is it clear? So this is the definition of dot product of two vectors. Okay. Now if you see, if A vector is written as A1 I cap plus A2 j cap plus A3 k cap, and B vector is written as B1 I cap plus B2 j cap plus B3 k cap. For example, these are the two ways in which the two vectors are represented. Then A vector dot B vector is written as A1 I cap plus A2 j cap plus A3 k cap dot B1 I cap plus B2 j cap plus B3 k cap. Is that right? Okay. Okay. So if you see, then this and this. So there are three terms here and another three terms here. So three terms and three terms are getting multiplied, which should give us 9 terms, right? So if you look at the 9 terms, they will be like this: A1 B1 into I cap dot I cap. Are you able to understand? So A1 B1 into I cap dot I cap, because between vectors, what kind of product are we using? Dot product. Plus A1 B2 I cap dot j cap plus A1 B3 I cap dot k cap plus A2 B1 j cap dot I cap plus A2 B2 j cap dot j cap plus A2 B3 j cap dot k cap plus A3 B1 k cap dot I cap. So A3 B1 k cap dot I cap plus 1 minute. I need a slide. Plus A3 B2 j cap dot I cap. Actually, I'll do one thing. I'll write 1 minute. I'll write the whole step here. A1 I cap plus A2 j cap plus A3 k cap dot B1 I cap plus B2 j cap plus B3 k cap is equal to A1 B1 into I cap dot I cap plus A1 B2 into I cap dot j cap plus A1 B3 into I cap dot k cap plus A2 B1 into j cap dot I cap plus A2 B2 into j cap dot j cap plus A2 B3 into j cap dot k cap plus A3 B1 into k cap dot I cap plus A3 B2 into k cap dot j cap plus A3 B3 into k cap dot k cap. Okay. Now, if you observe, what is I cap dot I cap according to the definition of dot product? So I cap is A vector, another I cap is B vector. So A vector dot B vector will give you what? Magnitude of I cap into magnitude of I cap into cos of the angle between I cap and I cap. The angle between a vector and itself is 0 degree. So magnitude of I cap is how much? 1. Magnitude of another I cap is also, because they are unit vectors. And what about cos 0? So 1 into 1 into 1 is going to give you 1. So same is the case going to be between j cap dot j cap and the k cap dot k cap. But if I observe what is I cap dot j cap, so it is magnitude of I cap into magnitude of j cap into cos 90 degrees. So cos 90 is going to be 1 into cos 90 is 0. So answer will be 0. So I and j are perpendicular, x-axis and y-axis. Same will be the case between I cap dot k cap, and same will be the case between j cap dot I cap or j cap dot k cap or k cap dot I cap or k cap dot j cap. Am I right? Now what all will get cancelled? So out of the 9 terms, 1, 2, 3, 4, 5 and 6 will get cancelled. So what is that you're left out with? You're left out with A1 B1 plus A2 B2 plus, and this is what is A vector dot B vector. So this will be the final result. I'll tell you how to handle it. Before that, make a note of this. Is it clear? Let me know when to show the next slide. If possible, first try to do it on your own. Look at the slides. Done. Okay. So now you saw if A vector is equal to A1 I cap plus A2 j cap plus A3 k cap, and B vector is equal to B1 I cap plus B2 j cap plus B3 k cap. If you do the dot product between both, what will you get? A vector dot B vector will give you A1 B1 plus A2 B2 plus A3 B3. Means what is happening? The corresponding coefficients of I cap are getting multiplied. The coefficients of J cap are getting multiplied, and the coefficients of K cap are getting multiplied, and they are getting added. Okay. So if I look at an example problem, for example, if I give you A vector is equal to I cap minus J cap plus K cap, and B vector is equal to 2I cap plus J cap plus K cap, then what is A vector dot B vector in this scenario? It will be 2 minus 1 plus 1. So answer will be 2. Did you understand? So when you're doing, actually A is a vector, B is also a vector, but when you perform the dot product between them, what is the output coming out as? Coming out as a scalar. That is why dot product is also called as scalar product of two vectors. Am I clear with this point? Okay. So this is how you solve. When two vectors are given, right, you will not sit and write the whole proof again and again. Your job is only one thing. Take the coefficients of I cap, the corresponding coefficients of I cap, multiply, corresponding coefficients of J cap, multiply, corresponding coefficients of K cap, multiply with proper sign. You need to do the algebraic sign. See, for example, here there is a minus. If you miss the minus, the whole point will change. Okay, so the answer will be 2. Is this point clear? Right. Next is, yeah, give some examples of physical quantities that may be expressed as scalar product of two vectors. Okay, so there are some physical, because A vector and B vector are generic vectors, right? But you're going to have an application of the same thing in physics. So when you're talking about physics, you definitely need to have some physical quantities which can be expressed as dot product of two other vectors, of which the first one, which is a very famous thing which you learn, is work done. So work done is defined as the dot product of force vector and displacement vector. So it is the dot product of force vector and displacement vector. Is that clear? Similarly, the same work done can also be written as torque vector dot theta vector, where tau, this is called as tau. It's a Greek letter. It's called as torque, about which we'll be learning in detail in the 7th chapter. Okay, and this theta is called as the angular displacement. Am I clear with this? Are you able to understand? So work done is also given as F vector dot S vector or tau vector dot theta vector. Okay. Similarly, you have other quantity called as potential energy. Which potential energy? I'll call it as electrostatic potential energy. So you need not memorize all these things. It is only for your understanding. Electrostatic potential energy is given by the formula minus P vector dot E vector, where P is called as the dipole moment and E is called as the electric field. So it keeps on going like this. But this year, the two important quantities that you'll be learning are the first. Okay, just make a note of it with the heading. So you need the heading, along with that heading, make a note of it. Done. Shall I proceed? So write down the next heading as 1 minute. Okay. So listen, properties of scalar product of two vectors. Okay. Here we are going to discuss about the important properties of scalar vectors. Okay. First one is scalar product of two vectors A and B is commutative. Make a note of it. So heading is properties of scalar product of two vectors. So this is the heading properties of scalar product of two vectors, in which the first property is what? The scalar product between A and B is commutative, meaning A vector dot B vector is equal to B vector dot A vector. Is it clear? So A vector dot B vector is equal to B vector dot A vector. So I'll explain the proofs now, which is slightly related to mathematics. Okay. Listen to this carefully. If I take this as A vector and this as B vector, and if I take the angle to be theta, so you should know the fact that angles are measured in how many directions? In two directions. What are they? Anti-clockwise and clockwise. So if I do A vector dot B vector, means from A, if I have to reach towards B, I need to turn in the anti-clockwise direction. Okay. Then A vector dot B vector will be equal to magnitude of A vector into magnitude of B vector into cos theta. Am I clear with this? Okay. Similarly, if I do B vector dot A vector, then it will be magnitude of B vector into magnitude of A vector into cos of, you need to turn in the clockwise direction. In your mathematics, you would have learned that angles measured in the anti-clockwise direction are positive and angles measured in the clockwise direction are negative. So when that is a scenario, here you will have cos of minus theta, right? So this will be magnitude of B vector into magnitude of A vector. And remember, cos of minus theta is cos theta because it is the fourth quadrant. Since cos of minus theta is cos theta. If you don't know this, make a note of this point. Done. Next. So prove that the scalar product of two vectors is distributive over addition, meaning A vector dot B vector plus C vector will be equal to A vector dot B vector plus A vector dot C vector. Okay, this is the meaning of distributive over addition. Means finding the dot product of sum of two vectors is the same as finding the dot product between individual vectors and adding them. Okay, so for this there is no proof at all. It is okay, directly code. It's a mathematical operation. Clear? Shall I proceed? Third, show that the scalar product of two vectors. Show that the scalar product of two vectors is equal to sum of the product of their corresponding rectangular components. So this we already proved. So if you remember, if A vector is equal to A1 I cap plus A2 j cap plus A3 k cap, then B vector is equal to B1 I cap plus B2 j cap plus B3 k cap. A1, A2 and A3 are called rectangular components of A vector. And what are B1, B2, B3 called as? Are called rectangular components of B vector. In mathematics, you call them as coefficients. In physics, in terms of vector language, you call them as rectangular components. Rectangular components of B vector. Is this point clear? Then when you do A vector dot B vector, what will you get? What is it we got? Got A1 B1 plus A2 B2 plus A3 B3. That's it. So that's what they meant. Show that the scalar product of two vectors is equal to sum of the products of their corresponding rectangular components. Corresponding means A1 B1, A2 B2, A3 B3. Is that point clear? Shall I proceed? Right. Shall I proceed? Now see. So examples based on scalar or dot product of two vectors. So we are going to solve some problems. Before that, I'm going to summarize all the formulae that we have discussed till now. Okay. Now see. The first property is, the first formula that we will be using is A vector dot B vector is equal to mod of A vector into mod of B vector into cos theta. Second, if A vector is perpendicular to B vector, then what is the value of theta? Obviously 90 degrees. So if two vectors are perpendicular, remember, if two vectors are perpendicular, the dot product between them is always a zero. So in most of the problems, what they will do is, they will tell you that the two vectors are perpendicular, then find this particular rectangular component. They'll give you an unknown and say that these two vectors are perpendicular, find that unknown. At that point, what will you use? You need to use the concept that dot product of two vectors is always equal to zero for What kind of vectors? Perpendicular vectors. And what is the reason for it? A vector dot B vector is equal to magnitude of A vector into magnitude of B vector cos. Clear? Shall I proceed? Sometimes what they will give you is they will give you two vectors and ask you to find the angle between them. So if two vectors are given and you're asked to calculate the angle between them, then the formula that we will use is you keep writing in the order 1, 2, 3 other way. Okay. Then the formula that we will use is the same thing. A vector dot B vector is equal to magnitude of A vector into magnitude of B vector cos theta. So from this, what can I say? Cos theta is equal to A vector dot B vector divided by magnitude of A vector into magnitude of B vector. This is point clear? A cap dot B cap. You can write. So if you want, you can write it as cos theta is equal to A cap dot B cap. But generally, we don't use this formula because nobody will sit and find the unit vector of it. Instead, what you will do is you do the dot product. Okay, if you want to find the individual unit vectors, right, it's a waste of time for you. Because A vector dot B vector is easy. You already saw. Multiply the corresponding coefficients and write it. You know how to find magnitude of A vector and magnitude of B vector. Root of A square plus B square plus C square. You know that, right? So when you apply that, you will get number by number. Why do we want to complicate it? Okay. So in terms of rectangular components, we have already seen this. A vector dot B vector is equal to AX into BX plus AY into BY plus AZ into BZ. So instead of AX and BX, I wrote it as A1 and B1. That's the only difference. Okay. Next is work done is what I told you. Force vector dot. So F vector is force and S vector is displacement vector. Similarly, there is another formula also. Power. Power is defined as, there is a mistake here. It is F vector dot B vector, where F is force and B is velocity. Don't call it as speed because speed is not a vector. Velocity is a vector. So the dot product of force and velocity is called as power. Ashwin Purida, write it down. Okay. Shall I proceed? Yeah. Now we are going to start problems. So the first problem that we are going to see is find the angle between the vectors A vector I cap plus 2j cap minus k cap and B vector is equal to minus I cap plus j cap minus 2k cap. Right. So what is the formula that is that find the angles? Cos theta is equal to A vector dot B vector divided by magnitude of A vector into magnitude of B vector. So what is A dot B? Ashwin solla. A dot B another A vector dot B vector. I told you multiply the corresponding coefficients. So what will be the answer? Minus 1. Minus 1. Okay. Can you slightly move this? Minus 1 plus 3 varad. Coefficient of j cap another first class. What is the coefficient of j cap? 2. We should multiply them. So 2 into 1 minus k cap coefficient Sham, you tell me. Coefficient of k cap. Coefficient of k cap. The first one. The first one. Oh, you're telling me the final output. Okay. Coefficient of k cap is -1. So -1, and what is the coefficient of k cap here? So when you multiply both, what will you get? That's right. If you tell me how to find the magnitude of a vector, root of, last class I gave it to you. Check your notes. Stuck in soul. I gave it to you on last Friday. Shivan, you tell me how to find the magnitude of a vector. Root over. Oh, how much is that? 1 square. Correct. That's right. Into square root of. You tell me how to find. So 1 square, or that is -1 square. Plus. Correct. Plus -2 the whole square. Correct. Okay. So what is the value? 4 minus 1. 3 divided by 4 were the 4 were the root of 4. This is root 6. This will be root. That is also 6 only. So you will get 3 divided by 6, which is half. Hari Raghav, cos theta is equal to half na theta evoda? 60. Sin 30 is half. Cos 60 is also half. So it is 60 degrees. If I have to write the same thing in radian, how will you do it? How much? 5 by 3. 5 by 6. 60 again. Sure. How? 60 into. Why did that pi by 180 come? How? I will come and tell you tomorrow 1 radian is 60 by pi. I wish. How did you know it was 180 by pi? That's what. So when you take a compass and rotate it through 360 degrees, how many radians are you covering? So 360 degrees is equal to 2 pi radians. So 60 degree will be equal to how much? 60 divided by 360 into 2 pi. So this is why you are multiplying with pi by 180. Answer is going to be pi by 3. Is it clear? So this can also be written as pi by 3 radian. I'm assuming that you have already learned this. Right? This taught, right? Shall I proceed? So mostly going forward, when you are trying to represent the angle, right, start representing them in terms of radians. Degrees will not be taken. Okay. So prove that the vectors A and B are perpendicular to each other. There is a property, there is a formula that we saw. When two vectors are given and they speak about perpendicularity, what did I tell you? Dot product between them should be 0. So A vector is equal to I cap plus 2j cap plus 3k cap. B vector is equal to 2i cap minus j cap. Right? Everyone know. Tell me the dot product. Hari Raghav. So A vector dot B vector. Everyone know. So what will I get? FD2. Okay. 2 plus minus. Okay. Plus 0. So how will you write k cap? Plus you will write it as 0 k cap. It will be 0. Answer is 0. So 2 minus 2 is 0. Hence the given vectors are perpendicular. Right? So whenever perpendicularity is needed, if you prove this, it is enough. Not only for this chapter, for any chapter. If two vectors are given, they say prove that they are perpendicular, do the dot product between them. If you get a 0, they are perpendicular. If not, they are not perpendicular. So those who are online are able to understand?
Yes, sir.
Shall I proceed? Shall I proceed? I told you, they'll give you an unknown and they'll say they are perpendicular, find that unknown. Same logic. Do it. So A vector is 2i cap plus lambda j cap plus k cap, and B vector is 4i cap minus 2j cap minus 2k cap. So their perpendicular means A vector dot B vector will be 0. So 8 minus 2 lambda minus should be equal to 0. So 6 minus 2 lambda should be equal to 0, which implies lambda is equal to 3. Okay. Now see the fourth one. If the magnitude of two vectors are 3 and 4 and their scalar product is 6, then find the angle between two vectors. So cos theta is equal to A vector dot B vector divided by magnitude of A vector into magnitude of B vector. So A dot B is how much? They have given it already. The dot product between them is 6 divided by magnitude of A is 3 into magnitude of B is 4. So this will go 2 times. This will go 2 times. So cos theta is equal to half. Theta will be equal to 60 degree or pi by 3 radian. Clear? Try this. So a body constrained to move along the z-axis of coordinate system is subjected to a constant force of minus I cap plus 2j cap plus 3k cap, and S vector is how much? Calculate the work done by the force in displacing the object through a distance of 4 meters along z-axis. Means how much is 4 k cap. So F vector dot S vector is how much? 12. So here this is in Newton, this is in meter. What is the unit of work done? Joule. Shall I proceed? Now do this. F into S, that is wrong actually. I'm not saying wrong. They would have not told you what will happen if it is inclined at an angle. Because if you see all the problems, they would have told force has displaced the object in the same direction. Okay. And at that time you didn't know trigonometry, so they'll obviously that formula is not included. So this is sixth problem, no? So there is a force of 7ik plus 6k cap, which makes an object move on a rough plane with a velocity of 3i cap plus 4k cap. So calculate the power in watt. Power is equal to force vector dot velocity vector. So what is force? 7i cap plus 6k cap dot 3i cap plus 4k cap. How much will it be? 21 plus 24. Answer will be 45. So 45 how much? Clear? Edra? Should be divided. Come again? 3 should 3. Be vector level. See, when you do the dot product between two vectors, the output you get is not a vector. Another, you will not put a bar on top of it. So there are three vectors, A vector, B vector, and C vector, such that A vector is equal to how much? B vector plus C vector, and magnitudes of them are, what is it? This problem I will do, but concentrate. So what did they do here? A vector is equal to B vector plus C vector. One vector is represented as a sum of the other two. Now what are they asking? Find the angle between A vector and C vector. So from this, can I write B vector is equal to A vector minus C vector? Can I do this? Right. Now see, what I'm going to do is consider B vector dot B vector. So the hint here is, whenever in a problem they have given sum of vectors, but the magnitude of they've also given the magnitude of vectors as well. I repeat it. They have given the sum of vectors. A vector is equal to B vector plus C vector, but they have given you the magnitudes as well. If these two information is given and they're asking you to find the angle, then you need to look at the vectors for which the angle is to be found. For example, had they asked the angle between B vector and C vector, I would have kept B vector and C vector on one side, the other vector on the other side. But what did they ask? Find the angle between A vector and C vector. So I brought A and C on one side. I left the other vector on the other part. So that is first thing. Second is, if you want to proceed, okay, if you have only two vectors, then that formula works. Cos theta is equal to A dot B by magnitude of A into magnitude of B. But here you have three vectors. So whenever you have three vectors and you're asked to find the angle, you're left out with one vector on the LHS, right? You need to consider the dot product of that vector with itself. So that's why I did a magnitude of, I considered B vector dot B vector is equal to, on the right hand side, in the place of B vector, can I write A vector minus C vector? Dot, in the place of the other B vector, can I write A vector minus C vector? So what is B vector dot B vector? It is magnitude of B vector into magnitude of B vector into cos 0 is equal to A vector minus C vector dot A vector minus C vector, concentrate. It is A vector dot A vector minus A vector dot C vector minus C vector dot A vector plus C vector dot C vector. Observe, this is still clear. Is it clear? Right. So this left hand side will be magnitude of B vector square into cos 0 is 1. Correct? So here one point to be noted is the dot product of any vector with itself is the magnitude of that vector square. For example, the dot product of B vector dot B vector was what? Magnitude of B square. This will be equal to, on the right hand side, I'll have magnitude of A square. And this one is plus magnitude of C square. And we know that A dot C is the same as C dot A, because what is the first property we saw? They are commutative in nature. So can I write it as minus 2 times A vector dot C vector? Can I do this? Now see what I'm going to do is magnitude of B is given. How much is it? 4. So here you have 16 is equal to magnitude of A square is 25 plus magnitude of C square is 9 minus 2 times A dot C is magnitude of A vector into magnitude of C vector into cos how much? Whatever is the angle between it. This will be equal to, tell me, 16 minus 25 is how much? 16 minus 25 is minus 9. So left hand side minus, okay, I'll do this. 16, right hand side you have 34. 16 minus 34 is how much? It is minus 18, which implies minus 18 is equal to minus 2 into, what is magnitude of A vector? 5, and magnitude of C vector is 3 into cos theta. So minus and minus are gone. This will go 9 times. So what will you get? I'll write it here itself. So we will get cos theta is equal to 9 divided by 15. Is this clear? So whenever you get something like this, right, you will write theta is equal to, take the trigonometric function on the other side, put a minus 1 here. You read it as cos inverse of 9 by 15. So this is the required angle. Am I clear? So did you get the whole idea of how to solve these kind of problems? Okay. So if you have understood, don't look at the board, write it on your own. You can't do it. As of now, you can't do it. You need logbook and everything. It's not needed, right? Shall I proceed? Hmm. 8-1. If you observe this problem also, you have if magnitude of A vector plus B vector is equal to magnitude of A vector minus B vector. Is anyone copying it? Want me to show this? Okay. If magnitude of A vector plus B vector is equal to magnitude of A vector minus B vector, then find the angle between A and B. So if you see, the sum of two vectors are A and B, and they are asking the angle also between A and B. So for these kind of problems, what you can do is square on both sides. If you observe what is the difference between previous problem and this problem. In the previous problem, they gave you the vector sum. A vector is equal to B vector plus C vector. Whereas here, what did they do? They gave you the vector sum and magnitude of it. So whenever magnitudes are equated, square on both the sides. So magnitude of A vector plus B vector square is equal to magnitude of A vector minus B vector square. Is this point clear? But in the previous problem, I told you A vector dot A vector is magnitude of that vector square. So can I tell it is the reverse also? So remember, A vector plus B vector is some vector. Okay. The vector's magnitude square can also be written as A vector plus B vector dot A vector plus B vector. Am I right? Is this step clear? This is a crucial step. If you're clear with this only, I can proceed. Is everyone clear? So similarly, tell me what will be on the right hand side. A vector minus B vector dot A vector minus B vector. Now you know two terms here, multiply them. So A dot A, magnitude of A square. Can I directly write it? Plus A vector dot B vector plus B vector dot A vector plus magnitude of B vector square is equal to, on the right hand side, what will you have? Magnitude of A vector square plus magnitude of B vector square minus, okay, wait. I'll write an extra step. First time it is difficult for you to write it like this. So magnitude of A vector square plus magnitude of B vector square minus A vector dot B vector minus B vector dot A vector. Accept it. Is it clear? So what is getting cancelled on the left hand side and right hand side? A square. So remember, magnitude is a number. So numbers can be cancelled. This and this will get cancelled. Gets cancelled. So what I left out with A dot B plus B dot A is 2 times A vector dot B vector is equal to minus A dot B minus A dot B minus 2 times A dot B, which implies 4 times A vector dot B vector is equal to 0. Am I right? So when this comes to the left hand side, 2 times A dot B plus 2 times A dot B, that is 4 times A dot B is 0. Then what is A dot B? 0. So if two vectors have the dot product between them as 0, theta is equal to, that's the answer. So angle between both the vectors is 90 degrees. Okay. I hope it is clear. Clear? So that's it for today. So I'm updating two things. You will be having two assignments given this week. I'll tell you what they are. One will be based on the concepts that we discussed, that is dot product of vectors and parallelogram. Okay, those are the two. Sorry, that will be as one assignment. And the second assignment will be on projectile motion. You derive all the formula to derive. You have to apply and solve them. Is it clear? So these are the two assignments that we uploaded. And I want everybody to work. I've been monitoring. None of you are doing the assignments for other subjects also. I've been seeing. But from next week, it will be taken strictly. Is that clear? Do not be let inside the class. I'm being very honest. But there is no point in learning and solving these many problems because you have to work and come. Or else there is no point in learning. So yeah, work and come. I'll upload them by tomorrow. So yeah. So any other doubts? Direction is that this is theta, this is r. I told you, in physics, direction means angle. This is alpha, this is a. To drop a perpendicular from here, this is a sin theta. Did you get this? This is, sorry, b sin theta, and this will be b cos theta. So what is tan alpha equal to? B sin theta divided by a plus b cos theta. So alpha will be equal to tan inverse of b sin theta divided by a plus b cos theta. This is the direction. And this expression is to be remembered. This is a very, very, very important expression. Remember it. Okay. So I repeat it again. In physics, wherever they ask you direction, it means they're asking you the angle. Okay, be careful. So yeah, that's it. We'll wind up, guys.
Thank you, sir.